Yo, what's good? Been a long day, had class, a lot of adult stuff. Thought I should deload with this video. Um, just a 3-day gap, not too shabby if I say so myself. Okay, so in this video I want to cover a logic quiz I gave my geometry students, and this will still be helpful for anybody, right? Because like I said, like usually these topics in logic they introduce first in geometry, but this is a huge branch of math in itself, or maybe I should say math is a huge branch of this. But yeah, it's very, very useful. Okay, so please listen. All right, so question 0, what is a statement? All right, so this is more of a definition question. All right, so Google this, but if you want, like what I was looking for for this answer is anything that's like, okay, a sentence that has a truth value. Okay, so for example, if you as a truth, sorry, I just said it. Okay, if you said "uga," okay, like that is not a mathematical statement because this is not a sentence. Okay, it doesn't have a truth value. Okay, if you said "hello there," hello there. Okay, this is a sentence, but it doesn't have a truth value. You can't put a truth on it. Okay. However, you could give me something like this: 5 is equal to 6. This is a statement because this is just a symbolic form for a sentence that and it has a truth value, right? We know that 5 is not equal to 6, so this is false, but it's just asking if it was a statement. Okay. Number 1, write the contrapositive of this statement. Okay, if you are on your phone, then you aren't giving me your full attention. Okay, subliminal message is what? Right. This one you need to see. Sorry, it's been a long time since I've used this computer. I just noticed I have like 20 different pens in here. All right, but here you should recognize that this is an implication. It's of the form P implies Q, or you could say if P, then Q. Okay. A contrapositive is also an implication, and the way that you create it is you first have to identify this format, right? P implies Q. So you have to identify the P and the Q, right? And the contrapositive of this, let me use this color. It's when you switch the hypothesis and the conclusion and you negate both of them, okay? There are many synonyms for hypothesis, conclusion. Sometimes they use premise and some other ones like antecedent and precedent. You could Google these things, okay? But I'm doing this on the fly, so I can't remember off the top of my head. But hypothesis and conclusion are the most common ones, okay? So here, yeah, so like I said, negate both of these and swap the positions, okay? So then that means the conclusion now becomes it's not Q, and that becomes the new hypothesis. You still put the implies, and then the hypothesis, not P, after you negate it, becomes the new conclusion. So it's just this. Okay. In this question, P is right after the if. So it's this piece. Let me highlight this instead. You are on your phone, and then the Q appears after the then keyword. Okay. And usually these types of questions, you're just trying to identify. You have to first see with the if and then are, and then you can find the P and the Q. Okay. So if I'm saying that this is P, you are on your phone, then not P would be you are not on your phone. And similarly, if I'm saying you aren't giving me your full attention, this is Q. So not Q would be it's not true that you aren't giving me your full attention. Or you could just say it's not you aren't giving me your full attention, meaning that you are giving me your full attention. Okay, hopefully that made sense. Okay, so it's like saying two knots, and that makes yeah, I don't, yeah. Okay, so this is a knot in here and there's a knot. Okay, so this, like I said, this is the contrapositive. It's going to be if you are giving me your full attention, then you are not on your phone. Okay. All right. Now, what's the truth of this statement? Well, the question didn't ask to evaluate this statement, right? It's just telling me to write the contrapositive, okay? And this is it right here, okay? All right. Number two, you can have ice cream or pizza is interpreted differently in mathematics. What is this difference? Okay, so what I was looking for in this question is that in mathematics, the or that they use is an inclusive or. They also have an exclusive or versions, and I hear that it's used a lot in computer science and stuff, right? But in general, by default, the math or that they use is inclusive. Okay, so in mathematics, this sentence means that there's the possibility that you can have both ice cream and pizza, whereas in English and casual conversation, when your mom or someone offers you this, hey, would you like ice cream or pizza? They usually mean the exclusive or. Okay. All right, I should stop writing. That took too long. Okay. Number three, construct the truth table for this statement. You could say not if X then Y. A better way of saying this is, it's the negation of this conditional. Okay. And how do you do this? All right. So I made this question a little harder because usually in geometry class, they give you the first two columns pre-filled, okay? With the four different possibilities, okay? But here, I wanted you guys to think about the four possibilities and come up, and derive it on your own, okay? And that ties into another math topic. It's accounting, right? And you're just seeing what are the options. Also, this problem's a little more annoying because usually, for statements, for some reason, the letter P and the letter Q are the most common representatives for statements. It's like, when you first learn math, algebra, they use X and Y to represent things, right? For functions and stuff like that, variables, right? But here, X and Y are not numbers, right? These are they're supposed to be statements, okay? So, well, if X is a statement, then by definition, it has to have a truth value. So it could only be true or false, right? And similarly, Y is another statement, and that could only be true or false. Now, where are the four choices coming from? Well, the first choice is if X is true and Y is true. That's the first one. The second one is if X is true and Y is false. The third one would be if X is false and Y is true. And the fourth, if both of them are false. Okay? So you could just put this here. Sorry, TF, FT, and FF, okay? After that, I think this confused students a bit because they're like, what the hell is this for, this column? What I wanted you guys to do was first find the truth value for this. X implies Y, and then you put that here, okay? You put that here, and then after you get all the entries here, to find the one that they told you, which is the negation of that, you just simply negate, you just make it the opposite truth values that you get here, okay? Now the question is, how do you get this one? Well, I mean, one way is memorize it, okay, which is a bad thing to do, but in high school, I think sometimes, like, you can get away with some of these things, and I think this is another video in itself, explaining why that each of these make sense. But let me just tell you what they are. When you have the hypothesis is true, the conclusion is true, this implication is true. Okay, it's actually true for the other ones too, except for one situation, and it's the second one, where the hypothesis is true and the conclusion is false. Okay, so let me put the T's on the other ones, and you put this one as a F. Okay, all right, great. Now to find this, you just negate all the entries. So if in this first row, if X implies Y was true, then the opposite of that, the negation of that, is just false. Okay, second row, X implies Y was false here, so this is true. Third row, this is false, and finally this is false. Okay, great. Okay. Yeah, I'll explain this in another video. It's an interesting thing, and it comes up a lot in discrete math and stuff. It's super useful. Okay. 4, if P is false and Q is true, find the truth value of not Q and P. Okay. So here they gave you another statement. They call this a compound statement because it's it's a statement made up of other statements and also with more like logical connectives and stuff. Okay. But here, what did I do? Okay. They're telling you what P, the truth value is for P and for Q. So that means that each of these little pieces that make up this compound statement also have truth values, and ultimately that means that this statement would have a truth value. Okay. Now this is going to be very similar to like when you're substituting numbers into expressions in math. All right. If I'm saying P is false, then substitute that, right? P is false here. Q is true. Q is true, so that means not Q would be false, right? And then you have false and false. Well, that's an and statement. This is going to be false, right? And once again, yeah, I need a video on that too, for and, a truth table for and this not false, the opposite of that is going to be true. Okay, so hopefully I didn't botch this up, but yeah, just listen. If I'm goofing here on the screen, then just yeah, my voice takes priority. Okay. Okay. 5, change to if then form. Vertical angle pairs are congruent. This is super useful. Here it's saying that they're not really telling you specifically what vertical angle pairs, right? There's a particular one. So this is low key. You could think of this as an all statement, okay? Right? But there are many ways of saying this, but the one I was looking for, an acceptable answer would have been this. If two angles are vertical, then they are congruent. And that's equivalent to the statement I gave here. Okay. You could also say if you have a vertical angle pair, then that pair must be congruent. Okay. So those angles have to have the same measure. Okay. And that's a fact, by the way. So if I ask you what's the truth value of this, you just take it for yeah, it's true. Okay. It's improving. So number 6, find the contrapositive of not P implies not Q. You should have recognized that this is very similar to some previous questions, like number 3 and number 1. Okay. When I said that you negate the hypothesis and the conclusion and you switch their positions, right? Well, the hypothesis to begin with is already not. So you're saying not. So it's like 2 negatives and that makes a positive. So it's just P. And you're negating the not Q is not Q is going to be Q, and you swap. So this is just going to be Q implies P. Okay, and that's it. Right. The reason why I gave so many of these contrapositive examples is because they're hella useful, especially in higher math and when you're proving things. Okay, proving statements and stuff. Sometimes like a proof technique is to, instead of proving the direct conditional. And usually many statements in math are in the if-then form, the conditional, right? It's sometimes easier to prove the contrapositive. Okay, cool. What type of statement is the answer from question 6 called? Okay. So I took this from JMAP or something. You could argue this, that technically all of these it could be one of these, any of these, depending on what the original context was, right? But assuming that we're not being too nitpicky of things, what I was looking for is the original implication is this is the standard implication that people give. Okay, and comparing the answer we got here for 6 with this, when you have the conclusion and the hypothesis swap, you should recognize that this is the converse. Okay, so this is going to be A. And to do this kind of question, multiple choice, you should you need to be able to know the other ones, but so you should just like Google these and do some research on it. And if you have any questions, please ask. Okay. Number 8, which statement is the converse of this statement, the statement that they just gave, right? So if the sum of 2 angles is 180, then the angles are supplementary. Well, from number 7, we said that the converse is Q implies P, right? So here it's the same thing. You identify the P and the Q, and then you swap them, right? The P appears right after the if. So the P is the sum of 2 angles is 180. The Q is the conclusion, right? And usually, okay, and that appears right after the then, okay? So P and Q. So the converse of this is when you put the Q as the hypothesis. So it's going to be if the angles are supplementary, then the sum of the 2 angles is 180. Okay. I don't remember what choice that was. Someone help me find that. I'm by myself, so it's got to be me. Okay, so if the angles are supplementary, it looks like it's number 1. Okay. Yeah. Okay. All right. Number 9. Find the missing angle measures. Okay, so like I said, a lot of math topics appear in everywhere. Okay, so this kind of question, this is like algebra. Okay, you have to make use of a theorem or a math fact. The math fact is that in any triangle, that interior angles add up to 180. Okay. Okay. So here they gave you 3 interior angles. I mean, one of them is definitely known. This 35 is a constant, but these ones are in terms of y. So you're gonna have to use some algebra, right? So, well, if I said that the sum of the interior angles of any triangle is 180, you can use that fact. Okay, I have a triangle here. Okay, that means, and I have the angles given, right? So it's here the angles are 35 degrees, 3y degrees, and y minus 15 degrees, and that equals 180 degrees. Okay. Oh, sorry, let me add, because we're adding, right? It's saying sum. Okay. I should put this in parentheses here. Okay, to make it really clear that this is the third angle. If you wanted, you could have also swapped this, right? You could have said this one plus this one plus this one, or this one plus this one plus this one, right? So long as you have all the angles, okay? All right. Great. So, sorry. Yeah, so now, do you guys see how that math fact helped us create an equation that we can solve? I see there's one unknown, one equation. We can solve for that unknown, okay? So here we got to collect the y's, combine the like terms, and you can remove these parentheses because it's with a plus here. And if this thing, you would do, PEMDAS would say to do this first, but this is already in simplest form because you can't combine y and 15, they're not like terms. Okay, so here let me take out the parentheses, and that's the same, right? And then now you combine like terms. Okay, I see a y here and I see a 3y here. The coefficient of this y, that's like saying there's one y in front. There's one y here and there's 3 y's here. Well, combining like terms, this is just 4y. Okay, 4y, and then you have 35 and you have minus 15 is equal to 180. I took out the degrees because you don't really need it here now. Okay. So you have this and you continue combining like terms. Okay. Well, look at the left side of the equation. This is these two are combinable. This is like saying 35 minus 15, that's 20. So you could put this here in the front, 20 plus 4y, or you could put the 20 in the back. So you could say 4y plus 20, but then you got to include that imaginary positive in front. So I'm just going to put it like this, 20 plus 4y is equal to 180. Okay, and now we can solve this. Okay. Get y alone. subtract 20 on both sides. It's one way. You can also divide by 4 for something. It's sometimes the numbers become more annoying in fractions and stuff. Okay, and then you get 4y is equal to 160. And now you divide by 4 and you get y is equal to 40. Okay. And let me just double check the question. Okay, so this is a common mistake. So students will be like, okay, that's the answer, right? No. Okay, you got to read carefully. Sometimes it says solve for the unknown, solve for y, but here it says find the missing angle measures. Okay, so you have to find out these values. Well, the 35 you already did. Okay, we now know why because of all of this. Okay, y is 40, so now we could just substitute this y, this value 40, back into both of these angles here. Okay, so 3 times 40, when you substitute with the parentheses, the number touching the number means times. This is equal to 120. So it's 120 degrees. And this angle here, 40 minus 15, that's 25. So this is 25 degrees. Okay. So the answer would be 35 degrees, 120 degrees, and 25 degrees. Okay. And if you wanted to label this, give these corners or vertices names, you could call ABC, and then this angle A is equal to this or something. Okay. All right. Now, how do I know this is correct? Well, use that math fact. Okay. The math fact was that the sum of the interior angles of any triangle have to add up to 180. Okay, so let's add up the 35, the 25, and the 120. You do that, 35 plus 25, that's 60. 60 plus 120 is equal to 180. That's correct. Okay, great. Whew. All right. This bonus question. Okay. All right, so this one was more, this is also algebra based, okay, but also geometry because it's testing your knowledge on certain vocabulary words in geometry like perimeter. Okay, so here, use the pattern. Each figure is made of squares. So this is another geometry word, squares that are 1 unit by 1 unit. Okay, so they're saying that the okay, well, first of all, if they're telling you it's a square, that means all the side lengths are the same. So they don't need, so this is kind of, this part's redundant here, okay? But they're just being nice, okay? I took this from a textbook, and at the end of this video, I'm gonna, I'll make an announcement on this, okay? Yeah, so made of squares that are 1 unit by 1 unit. Well, and perimeter means that's the length of, it's basically the length of a 2-dimensional shape's boundary. Okay, so the way I teach this, because this is 2-dimensional, you think about, this is a triangle, right? You think about this as a string, you cut it with a scissor, and then you expand the string, okay? And then you take a ruler and you measure that. That's the perimeter. Okay, so here, they're telling you that this is a square, and one of the sides is 1. Okay, so this is 1, and this is 1, and that's 1, and that's 1. Okay, the unit they didn't give you, it's not inches or feet or something, it's just unit, right? So if you add up all of these, you get 1 plus 1 plus 1 plus 1, that's 4. So the perimeter of the first figure is 4. Okay, then you go and do the same thing with this, right? This shape is like a Tetris piece, right? So you could do the same thing here, right? You add this, that's a 1. Let me erase this, I need space. That's a 1, 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 that's a 1. That's a 1, and that's a 1. Okay, so when you add this, you get 1, 2, 3, 4, 5, 6, 7, 8. This becomes 8. Okay, and then you do the same for the other ones. That's 3 here. That's 3. That's 6 already. 7, 8, 9, 10, 11, 12. So this is 12. That is really big. Okay, better. Okay, okay, 4. Okay, so it's 4, 8, 12. Huh? Looks like there's a pattern here. Okay, now the number 4 here. That's 4. That's 4. That's already 8. Right, and then count these again like this, or you could even go like this. So it's 8 so far, right? 9, 10, 11, 12, 1, 13, 14, 15, 16. Okay, so this is 16. Okay, all right. So it looks like the pattern is 4, 8, 12, 16, and this should be 20. Okay, and you could also check this. Okay, this is 5 and 5, and you will see that this is 20. All right. So here, find the perimeter of each figure. That's done. Okay. Describe the pattern of the perimeters. Okay, so you could say the pattern of the perimeters, maybe I should type because I've been talking a lot. Oh, no, not that much space, okay? The pattern of the perimeters, it looks like the perimeter is 4 times the figure number, okay? Because remember, this is figure 1, so 1 times 4, is that 4? Yes, it is. 2 times 4, is that 8? Yes. 3 times 4, 12. So I would take that as an answer. Okay. Now it says find the perimeter of the 55th figure. Okay. Find the perimeter of the 55th figure. Okay. So here, based off of this pattern that they gave, there's going to be a picture for 6 and 7, 8, right? But you're not supposed to draw all of these, right? You're supposed to just go down, dot, 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 all the way to the 55th figure. It's going to be huge, okay? Okay, and you need to get this. Okay, well, in part A, we said that this is, P is, the perimeter is equal to 4 times the figure number, okay? Well, the figure number here that they gave you is 55. So here we just substitute. So it's P is equal to 4 times the figure number. That's 55. Okay, whatever that is. Okay, so what is that? 220. Okay, this is 220. P is equal to 220. Okay, units. And that's it. That's it. Okay, just want to say something. This topic also ties into sequences, okay? So here, to find the perimeter of the 55th figure, you're assuming that this pattern works, but for all you know, we don't know what the heck happens at the 6th figure, the 7th figure, the 8th figure, right? It could just troll you or something and make it constant. But yeah, in practice and math problems and stuff, you don't need to worry about those Illuminati cases, okay? But just saying, okay? This is just testing your deductive reasoning skills, okay? So yeah, okay. Yeah, hope you guys are well. Let me, before I forget the announcements here. So like I said, I took this from a textbook, right? Free math e-text will be, and I'll be using these in the future, okay? So which one? Okay, so I'll put this in the description box below, okay? Yeah, this is kind of annoying because you have to, click on one of these and you go by the section, but it's free, so, and which is good. Okay, so yeah, there are other ways of doing it, but this is a good way. Okay, all right, and then yeah, read up on this, and I'm going to be using this as a text, and hopefully you guys can follow along and whatnot. But yeah, please ask questions. I know it's scary because it's YouTube and stuff, but I can't control all all the freaking trolls out there, but try your best, and hopefully I don't have to become some kind of YouTube mod to filter those people out. Waste of time, right? Okay, so here, and then use an alias if needed, okay? Or if you don't, just give no Fs, and then just be courageous, and that also works too. Also, number 3, I've been using Zoom, okay, but since I'm trying to get more professional and stuff, I was looking into OBS, so stay tuned for that. But right now I'm an OBS noob, so yeah, sorry about that. Okay, all right, guys, take care. Hope you're doing well, and be good. See ya.